he's going to give us a short presentation about his group, and initially he's going to speak first about what this XPRIZE is all about.
Hello, I'm Robert from the German team Part-Time Scientist, and yeah, I will tell you a little bit about the Lunar XPRIZE because it's a very exciting competition set up by Google, and we are all part of it. So everybody, we're all doing cool stuff with web prototyping for space, and the reason we're doing it is because of the Lunar XPRIZE. So the Lunar XPRIZE is a $30 million competition set up by Google and the XPRIZE Foundation back in 2007. So they were really just the two guys from Google, sitting there and thinking that exploration in space is of course happening, but not as fast as it could. Because if you think about it from yourself, you know things like Star Trek, Star Wars, you're really excited about space. But if you look at what's happening, then there's really slow progress. So of course we have things like the International Space Station, and we're having a Mars rover, which is great, which we have 3 right now. But if you look at how the time and how long it takes and how much it costs in terms of money to get something into space, we're really at that end right now. So for example, the latest Mars mission cost $3.5 billion. That's a whole lot of money, and the point is that they could afford this once, but the next time the NASA says the next time they can afford a mission like this will be not before 2020 or 2025. So we really see that the key to do something more often in space is to get things cheaper. And that was the motivation by Google to say, okay, we're giving $30 million to the first team who privately sends a rover to the moon. So, and that is what the competition is about. So the GLXP was inspired by the Ortiz Prize. So the Ortiz Prize is one of the most well-known examples of a prize sparking something revolutionary in history. So back in 1920-something, we only had a very few airports, which were mostly based in Europe and mostly based at military sites. So normal people couldn't just enter a plane and fly from A to B. It was just impossible. So, and there was one guy who was Raymond Ortiz, who was a hotel millionaire by the time. He really had a lot of money. And he really said that he thinks it shouldn't be impossible for normal people to fly, and it should be possible to actually cross the Atlantic. And by the time everybody was saying, no, it can't be done. And he said, okay, I'm giving a large amount of money to the first person who proves to me wrong, proves that this is possible. And we all know what happened in history. Charles Lindbergh was the one who proved that this is possible. He flew over the Atlantic with the Stewart of St. Louis. And 5 years after Charles Lindbergh did that, we had a really full aviation industry. So we had dozens of companies all around the world. We had airports opening up, and today you can fly for less than 30 euros to Mallorca. So, and this is something that is really extraordinary, and that is what inspired the guys from Google to launch the Lunar XPRIZE. And this is the same motivation I think that applies for our team, and I really believe it also applies for many other teams, to make way that we can go to space much more often. Why not go to the moon every year? The last time we were on the moon was 43 years ago. And the last man who set the foot on the moon was the only scientist to ever walk on the moon. Everybody before him were just military personnel. So we just put one really intelligent guy on the moon. And this was 43 years ago. So we really know just nothing about the moon today. We know more about Mars than we know about the moon. And that is the reason why the moon is a really good starting point to get back to space. Okay, so let's have a look at our team. So I'm from the Part-Time Scientists, we're a German-based team. And yeah, we're a team of 70 scientists and engineers with a hardcore of 30 members, which are working most of the time, actually part-time, but we also have some full-time members. And we're having 50 industrial partnerships, so we're cooperating this. And these are partners where we try to develop technology in a way that it benefits both sides. So we'll come to this in regards to 3D printing. And yeah, that's basically our team. So we're based in Berlin, Germany. We have a location in Hamburg and in Salzburg. All the engineering happens in Salzburg. All the electronics, radiation hardened electronics development in Hamburg. And the boring stuff, that sticks with me in Berlin. I do all the legal work, which is boring. But somebody has to do it. So the place where we want to go on the moon is Taurus Littrow. Taurus Littrow is actually the landing site of Apollo 17. So what you can see over here, not just the blurry lights, but actually this landscape, the moon itself really looks like a dune area. So why is that so? Because the moon is covered with lunar regolith, something very important. And lunar regolith is the lunar dust, the soil, that makes up the first 3 meters of the lunar surface area. It is created by meteorite impacts and by a surface friction that is always happening around the moon. So one thing that's quite unbelievable but that is still happening is that there's dust particles traveling around the moon at 1 and 2 meter height all the time. So the moon is constantly being swept by dust particles. So these particles get finer and finer and finer each time they collide and sweep against each other. So you really have some sharp, fine-grained particles. The good thing about this particle, the bad thing is that these particles really get everywhere. They destroy everything they get inside. So give you an example. The Apollo astronauts, they had airtight suits, of course, to walk on the moon. The thing is, what really frightened the astronauts when they got back into the Apollo capsule is that they noticed that their hands and arms were all black because the lunar regolith got inside the airtight suits. That's something that's scary. So you have a suit which is airtight, but these particles are so small that they can't get inside. Which means that NASA was quite worried that these guys inhaled this stuff and had it in their lungs. So, which means if you get lunar regolith, for example, in your lunar rover, then the chances are really good that it will break down and not move like any 2 meters. The good thing about lunar regolith is actually its meteorology, I don't know, the weight, the composition of the material. So it has a very high amount of iron particles, and of course it contains something that's well known as helium-3, but let's not talk about helium-3 as an energy source. Let's have a look at regolith itself. Regolith itself is actually a perfect particle that you can use for 3D printing. You can actually break it up and melt it. That is with high energy. The point is, high energy is something that you have quite easily available in space because you have the sun and you have no atmosphere around the moon. You have to think about the environment on the moon. The moon is really a really harsh environment. It's our closest neighbor, and we always think about Mars, and Mars is unfriendly with like 40 degrees, 40 to 80 degrees at daytime and minus 40 degrees at night. But the moon is really so much more harder than Mars. The moon has minus 125 to plus 125 degrees at the same spot over the course of a single lunar day. And it is instantaneous. So luckily there are no clouds on the moon. So if you encounter a shadowed area, you enter this shadow, then you immediately cool down to minus several degrees, not actually minus 125, but cool down significantly. So you need to build technology that does not fall apart when it gets heated up and contracted really fast. So much about the moon as an environment. So it really has some really good particles that you can use for melting and working with this stuff. And you have really good access to the biggest energy source that we have in our solar system, which is our sun, because you have no atmosphere, so you get direct sunlight, which is perfect if you want to power, for example, lasers based on solar panels. Even some people who use optics for this. So now let's talk about 3D printing in space application. The most obvious thing, I start right at the front, is really the most obvious thing. So everybody, of course, who knows 3D printing will just start creating prototypes with it. So, for example, when we design new rover prototypes, we just order all the parts and 3D print it because it's the quickest way to figure out if something went wrong. Of course, you have people doing this CFD work, looking at all the parts and seeing the cable wires where they go. For example, if you order these parts as 3D parts, you can easily see, okay, I forgot this part, I forgot an opening to get the cable through, for example. And if you have this part 3D printed, then you can quickly modify it. You can just use a drill and put a hole in it. But of course, if you would do it the normal way, and order these parts, metal parts, then you would actually be stuck because it was not so easy to modify this part. So 3D printing really gives you the option to quickly verify your designs. So in our case, this were just 2 rover prototypes that we used. And one approach that we have when it comes to quickly develop prototypes for private space exploration is to start with design studies, which is something like this little guy, where you can easily use 3D printing. You just have an idea, print out this idea, assemble this prototype, look at it and say, okay, it's moving the way it should move, and then I build a better one. And then we have this revision 3 in our case, where we test a certain technology. And revision 3 is that where we currently are, where I will show you in this moment, is this prototype that you're going to qualify, that you get ready for the moon, that you will put onto a rocket and send to the moon. So, of course, this is just 3D printing prototypes. So I will probably see a lot of 3D printing parts around here anyway. So one thing that's also good about 3D printing is that you can test actually to build prototypes which are too large and too expensive to build right away. So for example, what we're currently building is a large-scale flight-capable prototype of our lunar lander, which we want to present in August this year. And this is really a big unit. It's huge, it's heavy, it's like more than 2 up to 3 meters in the diameter. It's like 2.5 meters high, and it has fuel tanks and parts like this. So the easiest thing to just see if everything really works out, why not do a 1 to 10 scale model of the parts on a 3D printer? It's a quick way to do it, and that's the cool thing about 3D printing. That's the obvious stuff. So this is just, I will go quicker through it so that others have time. So this is just our lunar rover that we want to send to the moon. This is Asimov. And the things that made up this rover is that it has an active suspension system, so it can lift and make one wheel. You have the thermal management, which is very important because you have all kinds of electronics in your lunar rover. And you really need to watch out if you have plus 125 degrees, and then you have electronics inside your rover, which is it's really hot on the moon, and you need to get rid of this heat. One thing that we came up with is a thermal management system, where we radiate heat and we use the capabilities of the lunar regolith as a heat reflector, which is something that works out quite nicely. And of course we have a tiltable solar panel. The reason why it's tiltable is that you can always aim it at the optimal sun angle. A solar panel which is aimed directly at the sun gives you the best amount of energy that you can get from the system. And of course you need stereoscopic cameras and seals that can keep out the weather. Okay. So now we're going to get one example for 3D printing and space applications. So one thing that we have, of course, is the wheels. You always look at the wheels in a place that you're trying to print out, trying to find out a wheel that really sticks good to the lunar surface. So you try out different designs, you can simulate them in a computer, that's what we did, and we tried them out in the lunar lab and realized that there is something happening that we didn't see in a computer simulation. So one thing that we noticed is that every time we tried our wheels, which previously looked like a little bit like these parts, which are CNC, that they always ended up piling up lunar regolith near this wheel center. So that means that the rover had to wait to dig itself into the ground. So this is something we tried to simulate it, but it really only see it in practice. So the point is trying out these parts in CNC really takes ages and is quite expensive. And that is the reason why we ended up using this approach of the wheel that we finally choose to go for. And this is actually one part that was CNC originally, and the next one we'll see how we do it right now. And this is a part that is extremely complex to make on a CNC machine. So it takes more than 3 weeks. It's less than 1 millimeter thick. It has the profile it needs, and it does not dig itself into the ground. But the problem is it's really hard to make. And one thing you have to understand, the harder parts to make are to make on a CNC machine, the more stress we put into the material. So now you think of stress, not something like burnout or something like this, but stress is also in level parts. So if I stress this part in its manufacturing process, I have a problem that this part is no longer as stable as it would be as being an aluminum block, for example. So something that we've been using, and I think there's something that you also may have heard of or not, is laser melting. Laser melting, for example, of titanium. So if we use laser melted titanium parts, you can achieve exactly the same result quite easily. You can do much more because you can print holes into the parts itself. For example, for cabling holes, which is really cool. Actually, there are companies here in Europe which manufacture entire working thrusters just out of titanium, 3D printed. So they print out an entire thruster, and the thruster itself already contains the fuel pipelines. So you don't need pipelines connected to the thruster, which is one of the most critical parts that you have because they can come loose, something can get stuck. And this is the reason why 3D printed parts in this case really help you to reduce the risk. And in our case, this little part is of course 3D printed. And 3D printing is a neutral process when it comes to stress. So of course the particles are melted against each other, which means that this part in itself is neutral from its stress point of view, which means that you can apply more load on it. Can endure much more, forces, that's the right term I'm looking for. And which is something that's really helpful because we're launching with a very hard launch provider, and this is shaking up everything that we have in this. This is what destroys the cable. So and I think this is something that's the most important thing. The only thing that remains is the hammerhead, but this is more a general thing. So of course we use 3D prototyping to test out designs before they put them in production. So really, by now we're really switching to using titanium-based 3D printing for all parts of our mission. So the entire rover that we will have is currently being completely printed out in titanium-based 3D printing parts, which is
for once expensive, but it really has much less weight than the normal parts. Something that, I don't know, maybe is interesting if you've tried out rapid manufacturing on your own, is the lessons that we've learned at least. So rapid manufacturing is really cool, and you can print your stuff at home. And as I said to you, we order all prototypes right away on the very first day when we have the drawings finished, but it's not perfect. It's good, but there are some drawbacks. And one thing that we learned is that, of course, these parts, they are made of plastic, so they really can't hold the entire weight of the structure. So what you can see here is that, of course, this part was originally in the CHP designed to be an aluminum part, and it's really just bending its way, so it's not working. This mechanism is failed. And this is something, I don't know, it's obvious when you see it, but it's something that you don't expect when you're just sitting in front of these CHP files and think like, oh yeah, I'm ordering this as a 3D printed prototype just to see how it looks like. So prototypes for 3D printing, you need to modify them. That's the point. Something that is people always forgetting about. Most of the time, people forgetting about this to do CNC work as a day job. So this is what it actually looks like if you do it the right way. Yeah. Okay, so that's basically fast.
Thank you. I'm going to pass the mic. Actually, I'm going to give a different mic to Alex. So you can also introduce their project, PlanB. With some physical form of presentation instead of showing slides.
Hi, I'm Lunar XPRIZE, and we are team PlanB, and we are from Vancouver, British Columbia, Canada. And I can skip right now over to explain everything about Lunar XPRIZE. Actually, in our team, 3D printing is not only the manufacturing tool, but actually a final goal. Goal is that Google Lunar XPRIZE is one stuff which was bringing us close to the moon, but you need to have some fine goal which will be justified whatever your steps you do at the beginning and till the end. And this is a 3D printing of any part, whatever is required, on a lunar surface. This is whatever our ultimate goal, which we put it in top of our mission. Maybe we will not reach this on the mission like in Google Lunar XPRIZE, but we will do everything on each step which will be confirmed that we are close to that main goal. And how 3D printing is important, I can just skip on this one because you're already aware about all this. I just tell them my experience, our experience with the 3D printing. First of all, prototyping. No question, this is whatever when you need to create something which is physically looks like this wheel. And better that you will be not spend the time on physically manufacturing the wheel, but actually just sitting in front of a computer and do the design by clicking on the mouse and using different tools like this which you are doing. Second one, weight. If you go into the moon, normal way as it was done by big space agency, you assume that you have enough resources, enough weight, and you better design everything like from titanium. And but in this case, you shouldn't worry about the money. One of the nice examples, when we was in the NASA Lunar Institute, was the position of a NASA. If 20 million is not allocated, there is no curiosity about curiosity. Google Lunar XPRIZE, as Robert explained it, $20 million. And this is like big space agency is thinking big, and as a result, they sometimes care, but sometimes practically not care how heavy will be equipment which goes to the space. And metal is not a good choice, even if it's titanium, or even if it's a lithium, aluminum kind of alloy. As a result, you have to find using the 3D technology, which will allow you to create something from carbon fiber. How to create it from carbon fiber if there is no 3D printers which will be doing this from carbon fiber. All right, you taking whatever you knew, and you create the mold. And when you create the mold, you just only needed nice epoxy, which made in Germany, which is perfectly fitted into the oven. You know, before you will place your before you place anything into the rocket, which will fly to the orbit. You need to be sure that it will be working without outcast. And to make this carbon fiber, you just make this one. This is whatever prototype, and this is what you really need to make. And you have to make the carbon fiber. And how you make this carbon fiber? You take in the same 3D printing technology and create mold. This is the same plastic, but you have to make sure that this plastic will be compatible with your epoxy, and it will be compatible with temperature, where your epoxy have to be solidified because different epoxy have a different solidification temperature. After this, you have to talk to woman, skip it to not this type of carbon fiber in cells. And voila, using the 3D printer technology to create, we don't directly use it, it's using the system mold. But finally, we get that piece which will be finally goes into your oven. And at the end, when you need like to put all these pieces together, you need somehow to make the blocks like this. And if you need that it will be looking like this, you need some kind of holder. And you also needed to put some epoxy and glue them together through the same epoxy. In this case, you need another 3D printed technology, which is EVA, you know, the glue, EVA glue. And you print it from this EVA glue, you put everything into epoxy, all these parts together, wait in an oven when it will be solidified, and after you insert them into the water, and glue disappear, and you have your final view is which you're doing. Second part of the experience which I have is the 3D printing. It's actually very interesting technology, but I would say that there is a alright. You get your 3D printer, you put it on your table, you try to place all parts together, and you just figure out it's not enough 1 evening, 2 evenings, 3 evenings, 3 weeks, and after this when you run it for 4 weeks, when you try to run this 3D printer, you just realize that non-engineers, for sure you are not engineers because you're software and you're assuming that it will be easy, but none of the engineers actually look at 3D printing by itself, like to make it design simple so that it will be easy to work with it. And I would say that 3D printing today is in a stage of this famous spirit of St. Louis flight. It still required engineering to design the proper 3D printer, which will be allowed to automate the process when you need to manufacture something from carbon fiber or when you need to manufacture something else. For example, when you are going to the moon, you need to mine. Alright, you need to somehow to make the mine. And what you do, you print in the mine. Okay? This is a silver. And you have to find the way how to print the silver. And this is also needed like to consider it like different materials. And when Robert talked about the titanium, I wouldn't go as far as the ideas of a titanium, but sometimes you are really limited in a case when you can order something from a big manufacturing 3D facilities. Like my friend living in Minnesota, and somewhere from nowhere, I asked him, like, can you drive this 25 minutes from your place? And he drives and tells the tires, you wouldn't believe this is just big, huge warehouse, and in this warehouse there is this like line up of 3D printers, all of them printing for United States military and from NASA. And sometimes the guys like we are, it's hard to ask to print on their printer something. Is it will be big price or it will be hassle? And as a result, you need to figure out by yourself how you will be printed from a titanium on a table. And the same technology can apply. You create mold, and from mold you take the titanium. Now you need to find the vacuum oven. Now we need to find the glue, which will glue all together, and this is all business of space 3D printing. You every time have to invent something.
Thank you. So next I'm going to ask Miklos to talk about the Puli space project, which is our Hungarian entry to the Lunar XPRIZE.
Like communities are saying everything about the basics and the other things, so I suppose I will skip the basics because my presentation first part will be what we have here possibilities and realities here in Hungary. We have 3D printing methods. Actually, we are using 3D printing as a tool. If you need a screwdriver, you use it. If you need a hammer, you hammer it on nail. And if you need a part very fast, you model, I print it. So it's just another tool like any other machining method. So we using available technologies, not like the competitors like to make something very nice things. We're simply developing a roller and things happen. So I would like to share something with this process. So the possibilities to use 3D printing, roller, area-based print components, housing for bearing, water, supporter, or covers, etc. Yes. Of course, we have advantages. I suppose everyone knows these. Of course, we have disadvantages that can reach. Okay. Actually, in Hungary, as the finance people told you before, we have only we don't have material printing, only the very small parts. So actually it's not real user. So we only use plastics. And the plastics, there are many disadvantages. The worst is the heat limitation, resistance to heat. So Robert said in the moon it's not very hot, so it's not a good thing if we use plastics we can melt. Okay, I suppose it's easier if I show some examples because actually I have all of them here. You can touch if you want after the presentation in time. We really show. So, that's all. Actually, the first part, which we use 3D printing, is not here because it's built in the robot and they don't have spare, so I can't show you. It was the rover gets heat, if it's, for example, for office somewhere or turns around, all of the load or the heat is on the motor shaft or the motor axis. It's not good. It can blow the motor so it's not good. But we needed something to take off the rope from the shaft. And what the solution was to use a bearing. Okay, not very strong bearing, but we can use. We always have problems with the light because we are going into space and every ground costs $99. So we can't use a very big ball bearing here. We need something very simple. And this simplicity is slightly weird. Actually, this is the part that we use. The process was that we cannot use lubricants because most lubricants are in space grade, like not alcohol. It's not very easy to use in space. And we need to be dustproof because as Robert said, in that cabin and the wall of the assembly can be broken in minutes or hours. So it might be dustproof and we cannot use lubricants. So the solution was to use something soft material, for example, plastics. And the idea was to use ABS because it's used in the industry very widely. And it was a very good idea. ABS can be printed. So you don't need to machine anything. And our first part of the program was born with printing this bearing for that. And it's don't need any lubricants, it works, that's proof, and everyone is happy. And it was fast to make it. The second example, I have a piece of this here. Actually, it's a dust cover placement. A rower has a very light aluminum frame, which means it's full of holes because it's light. And therefore, because we don't want the dust or any dust in the inside of the rover, we need a dust cover. A dust cover is a very light carbon based plate, and it's formed to a shoebox. Simple because maybe you see now rovers, unfortunately, they don't have really things like this. So it's a box. A rover is a box. The shoebox dust protection is two parts here, one up, one down. The other problem is with this that we have legs and go to this. And if we have holes, then the dust can go in very easily. So we need to place somehow the two parts together, and this is single 3D printed, again 3D printing because it was easier to do. There is no load, nothing, it's any material to do. So we do this, put in the shaft, and we can position without protection. Next one. Yeah, this is my favorite. Actually, I decided. So we had a problem because we had very enough power of the solar panels. So we decided to blow up the surface of the solar panel. For example, we don't need a solar panel to store them. So we created a very flat surface with solar cells, and it has no holes or anything on it. They are only solar cells. But we wanted to, it's easy, you can do it very easily, books like this, simply glue it. Oh, that's okay. But the problem was that this is a prototype and the assembly business is ready. So we need to somehow unlock that mountain this one, the parts and the solar cell. So we figured out these parts. Actually, it's two parts. They are connected to each other. And the requirements must that it needs to have some heat insulation because the solar panel can be very, very hot if the sun shines on it, especially in the moon. We have electronics inside the box, and that can generate extra heat. And if we heat up too much the electronics and everything in the box, that's really not good for us. So we have a simple gap and a heat insulation from the solar panel. And this stuff, we have 6 of them. Actually, the idea came from laptop that made noise. We have to put in the screw walls and the nuts. And it's very easy to mount, and this mount has a very precise, and it has a very good advantage because the screws are from metal, and the simple can use it to put the current from the solar power to the OS login. So if I simply put the solar panel in the OS, put in the screws, and everything is connected, it works. So that was our spacer for solar panel. Yeah, actually, this one is a so-called panel installable camera stand, or we call it I2. It's under heavy development. You can see it's all 3D printed. Actually, it's completely working and position and everything, but it needs some refination. It's our flagship project just now. We are working on it. Actually, it's needed because the GLXP, because they need selfies from the rover and they need panoramic images, and we need something like this to do that. So our rover is not enough. Okay, and the last one is actually it's the most interesting thing, but actually it's not a toy. We have plans to make a toy for kids from our rover, and actually this is a prototype made entirely from its 3D printing. It's completely working, just I don't have the camera panel for it, but it's a toy, it's a camera, it's can be controlled by Wi-Fi. So it's basically needs everything but our rover knows, except the solar panels and the charger. And that's for the attention. Actually, it's that a real rover.
Thank you for the presentation. Now, I'd like to use our remaining about 5 minutes to ask the question of did you consider actually bringing a 3D printer to the moon, like either to fix your broken or soon to be broken module, or for colonization purposes, or
I can answer this at least for our team. So on our rover we have 4 payloads, so-called block containers. So there's payload boxes, and one of these block containers is reserved for a specific experiment. We want to bring in something which is almost like a 3D printer for the moon over there, because we want to test out what kind of precise parts we can create of the lunar dust. So we really want to take some lunar dust in. We need to filter it through, of course, because we really just need to find powder. And then we want to see how we can mount it. So of course the future for space exploration, as was mentioned, is really to make part in space. Because everything that you need to get off the ground from here on Earth is really, really expensive, because you need a lot of energy. Energy always translates to fuel, translates to money. You can convert it in many ways, but you still need it.
So if you just build your stuff in space on the moon, because the moon has an atmosphere, there's no friction, you have 1/6 of gravity, you can build your entire spacecraft to head towards the Mars on the moon. And it makes much more sense to build it on Earth.
Definitely, the answer is definitely.
Yes, the answer is no. Not like this.
Okay, thank you. I think that this was a very exciting discussion, and we're just so professional that we're just finishing the time, so I think everybody's going to appreciate that. Of course, everybody's going to be around, so if you have questions, you can either ask right now, or you can ask later as well. So if there's any questions right now, just go ahead.
So the first one, when you are 3D printing in titanium with wood, if you find that you have the same tensile properties that you would machine it from a block, or has the same tensile properties?
It doesn't have the same kind of properties. It has, depending on what you choose, you can of course choose, you have different types of options. You don't have to use titanium, of course, you can use an aluminum-based composition. And it varies with the composition that you choose for the printing. So the thing that we want to choose actually is to have a part which has not so much of a heat transfer, because the sun is, as I said, it's at 125 degrees, it's shining on the wheels, it's heating up this part, and this heat crawls into the rover. So there's actually, the heat is stepping over every component. That is why, for example, it's important to offload, to have different parts of different compositions to get the heat out. It's also, you have to think about many things on the moon. So it's a little different than if you cut it out from cockpits.
Any other questions? Okay, so the next event is going to be half an hour here, so maybe you guys can, if interested, come up and look at the 3D printed prototypes and talk to these excellent gentlemen about their move and theirs. And the deadline for the prize is next year, right? So we have to see 2015, we have to see all of these projects go to the moon and walk half a mile and send back selfies, and everybody's going to be very motivated. So it's going to be very exciting next year for all these weeks. Thank you very much.